The question is, are these functions inverses? And I'm going to prove it, all right, why or why not? I'm going to prove it algebraically. I'm going to show that f of g of x is equal to g of f of x, which is equal to x. All right, I'm going to show that both of those are equal to x. All right, so I'm going to put g inside of f and then f inside of g. So I'm going to start out by writing f of x. All right, I'm going to do this one first. So I'm going to write f. I'm going to write 1/2 instead of x. I'll put parentheses plus 5/2. All right, and then now I'm going to put g inside of f. All right, so all of this is going to go in where x is. So I'll put 2x minus 5. All right, and now I'm going to distribute the 1/2. So this is like 2/1 and 5/1. So my 2's cross out here, and I have x. And then I multiply 1 times 5. It's a minus 5. 2 times 1 is 2. All right, so x minus 5/2. And then I have a plus 5/2. And then those add up to 0, right? These cancel out, and so that ends up being x. So far, so good. So f of g of x, right? If I put g of x into f, that did end up being x. So now I just need to do the second one. We put f into g. So I'm going to start out writing g. All right, so I'm going to write, g is my pink, so I'm going to write 2 parentheses minus 5. All right, because that's g. This is pink. Okay, so there's g, and now we're going to put f inside. So all of where I see an f, that's going to go in for x. So we'll put 1/2 x plus 5/2. Okay, so there is f, that's the black function, into g, which is the pink function. All right, and then now you just simplify. Okay, this is 2/1. All right, so when I multiply that, I get x, all right, because it's 1x. And then when I multiply that, I get 2's cross out, and I have 5 minus 5. That's 0, so I get x. All right, so yes, those are inverses of each other. All right, and I could write that out as a sentence. I'll say yes, because f of g of x equals g of f of x, which equals x. Okay, and so we're proving that by composition of functions. All right, so there is that. So now we're going to do number 4. Same thing. I'm going to put, all right, I'll say f is this one, and then g is the pink one. All right, so I'm going to start with putting g, oops, well, this just means x is positive. All right, that just means x is positive. So this is g, it's going to go in for x. So I'll write out f. I'm going to say square root, but instead of x, I'm going to put in g and then minus 4. And that's all under the square, all under the radical. Okay, so now I'm going to put g in to f, so that would be x squared plus 4. All right, and then now I'm just going to simplify. Well, I have my positive 4 and minus 4 is 0. So what's left is x squared and I'm going to take this under a radical, so the square root of that. All right, and the square root, these actually, this is like the square root, those are inverses, so that I get x. All right. And now, because it said here x is always positive, so I just write x. And then now I'm going to put f into g. So I'm going to write out g, which is x. Oh, so instead of x, I'm going to put parentheses, right? So it's x squared plus 4. Okay, so that's g. And then now I'm going to put f inside, right? So I'm going to put a square root of x minus 4. All right, that's f. So f is inside of g. And then now I'm just going to simplify it. Well, if I take the square root of something and I square it, all right, again, this goes away. For example, if I have the square root of 3 times the square root of 3, well, that's the square root of 9, which is 3. Okay, so if I have the square root of 3 and I square it, I get 3. Right? But what's inside comes out. All right, so this basically kind of is the inverse of that. It undoes it. So now I have x. Oops. So now I have x, right, because this made the square root go away. So I have everything underneath x minus 4 plus 4. And then you cancel those out and you get x. So when I put f of g of x, I got x. And then g of f of x, I got x. So both ways I got x. And the reason is this, okay? Composition of functions. And now I'll do the next one. Okay, so I'm going to go back to my color scheme here. So F is black and G is pink. All right, so I'm going to start writing F. So it's the cubed root of 2, and then for X, I'm going to put in whatever G is. So now G is 2x cubed. Okay. So I'm going to do what's underneath here first. So I'm going to simplify, get the cubed root, and then 2 times x cubed, so that would be 4x cubed. Oh, wait a second. I have, this is F, so X, I'm putting this in, yeah, putting G for X. Okay. So 4x cubed. All right, and so, so what I end up with is the cubed root of 4, right? And then this is going to be, these do cross out, right? I end up with the cubed root of x cubed, which is x, so I have the cubed root 4 times x. All right, so that did not give me x, so thank goodness I am done. So that is not an inverse. Okay, because I still have this guy, so that's an issue. All right, very good. So now let's look at number 6. It says determine whether these are inverses. F and G are inverses. Okay, and it's nice. It told us what to do. All right, so I'm going to do the same thing. F is my black function, and G is the pink function. All right. So I'm going to start writing out F. All right, so I get 3x minus 2. Okay. And then now I'm going to put G into it. So that is x plus 2 over 3. So G is inside of F. And I got, now I simplify, right? So this is 3 over 1, so these cross out, so I get x plus 2 minus 2, so that's gone, and so that equals x. All right, so that's the first part, right? This kind of helps me out because these are the two things I have to do. Now I'm going to put f into g. All right, so I'm going to start writing out g. I'm going to say, oops, instead of x, right, I put parentheses plus 2 all over 3. So I'm writing out g. So there's g, and now I'm going to put f into it. All right, so I'm going to put 3x minus 2. All right, and you always do your whole numerator first, and that before you would divide. And so 3x minus 2, and there's nothing to distribute here with these parentheses, so I can kind of ignore them. So minus 2 plus 2 is 0, so I end up with 3x divided by 3, and that's 1, so I end up with x. All right, so both of them gave me x. All right, so yes, this is f of x and g of x are inverses. Okay, because if f of g of x equals g of f of x, which equals x, and f of x I'll just leave it like that, and g of x are inverses. Okay, because they undo each other. They get x all by itself, and that's what the inverse does. All right, good work. I think that is the end of that. So we had a lot of practice here with composition functions.